Hello, and welcome to our next set of videos where we are going to talk about thermal energy exchange. We've talked about what heat and temperature are, and we talked about the three ways that energy gets transferred, heat energy gets transferred. We talked about the difference between thermal energy and temperature. Thermal energy being the total amount of kinetic energy in the molecules and particles of a substance, and temperature being the average amount. We looked at expansion and contraction. As things get warmer, they expand, and they expand linearly according to a formula. I believe our formula is right here. Delta L is equal to alpha L sub 0 delta T. And our volume formula expansion right there, delta V, is equal to beta initial volume times delta T. All right, now we're going to take a look a little bit more at heat and thermal energy. All right, so let's get started. Let's get a reminder of what heat is. Heat is the kinetic motion of the molecules and atoms, or the particles that make up an object. So heat, the kinetic. Now remember, kinetic means motion. And in this case, it's vibrational motion. The kinetic energy of the particles in an object. When something is hot, the particles of the object have a lot of vibrational motion. When something is cold, they have less vibrational motion. At 0 Kelvin, or about negative 273 Celsius, all vibrational motion of the particles stop. The particles sit still. Now, heat, thermal energy, which is what we call heat, thermal energy is calculated. Whereas temperature is measured. Okay, now thermal equilibrium. We got ourselves a guy lounging around in a hot tub here. The hot tub is 42 degrees Celsius. The guy's body temperature is 37 degrees Celsius. So heat energy goes from the warmer substance into the cooler substance. So the thermal energy in the water, in this water, I'm going to choose blue for that. The thermal energy in the water will go down as that thermal energy is transferred to the man, and the man's thermal energy will go up. And the fact that the man's thermal energy goes up means that his body temperature will rise. And it's not good for a human body temperature to rise. So that human body is going to need to do something to cool itself down. So now we look at the poor, sad man at 37 degrees Celsius. He's sitting in 20 degrees Celsius water. Well, this man's thermal energy is going down. He's losing thermal energy. He's feeling colder. And in the water, the thermal energy of the water is going up. So the temperature of the water will actually start to go up. This man is going to start feeling colder and colder, and his body is going to have to do chemical reactions in it to maintain the body temperature at 37 degrees Celsius. So in thermal equilibrium, when two objects when two or more objects are in contact with each other, they will exchange thermal energy until the objects are the same temperature. Right, and that's the whole point of a refrigerator. You take a warm object, you put it in the refrigerator, the thermal energy goes from the warm object into the air in the refrigerator, and the object cools down. Now the air in the refrigerator also warms up. So the refrigerator has to get rid of that heat somehow. And so it does that by pumping the heat out into a gas on the external side of the refrigerator. So this is what a refrigerator does. An oven does the same thing. You take something cold and you put it into the oven. The hot air in the oven transfers thermal energy to the cold item that was put into it, and the cold item that was put into it warms up. Now the cold item absorbs the thermal energy from the air, so the air gets cooler. So the oven has to come on again to warm itself back up. So this heat exchange always goes from the energy exchange goes from the warmer item to the cold. So the exchange, so energy always goes from warmer item to colder. So the one with the higher temperature loses, the one with the lower temperature gains energy. Now, remember, we talked about this before, heat cannot be measured. Like temperature, it must be calculated. And what we're going to be doing here is figuring out how to calculate it. All right, so that's thermal equilibrium. The fact that thermal energy is transferred between two objects in contact with each other. So in this case, the water is in contact with the human. And so the human loses thermal energy into the water.